Hello, good morning, good afternoon, and good evening. My name is Jade, and I do communications for Shell Marine. Thank you for joining us here today at our first ever Shell Marine and Man Energy Solutions webinar on optimizing the new 2023 service letters. We're delighted to host all of you today from marinas, academics, and the media from over 35 countries spanning across Asia, Europe, Middle East, Africa, and even America. So thank you to those who have woken up very early to join us today. Together with me today are my colleagues, Marcus Scherer, General Manager of Technical Services, and Dirk Hoek, Technical Product Manager. And we are also very privileged to be joined today by Jesper Mark Petersen, Head of Cylinder Condition of MAN ES, a renowned OEM of the industry. And before I proceed, we have a quick disclaimer to show, whereby please understand that the content that you will see today is purely for information sharing purposes. This is not supposed to be construed as investment advice. Over in Shell, we also prioritize on safety and health. So allow me to just say a few quick reminders. If you're at home, please make sure your workplace is ergonomically sound. If you're on site, please know your locations of the fire alarms, extinguishers, and emergency exits. And please make sure that the fire alarm is audible to you. If you're on the move, we hope you are not taking this call while driving. Please also continue to follow COVID guidelines. And in the event of any kind of emergency, please do leave this call promptly and safely. For our agenda today, we will be shortly listening to Jesper speak about the new 2023 service letters. And then Dirk will come on and let us know how to apply the latest cylinder lubrication guidelines with Shell Lube Monitor. And then Marcus will recap the key takeaways. Anytime throughout the event, please do ask us questions because we will be ending with a live Q&As with the speakers. So click on the icon that you see on the screen and type in your questions. It's optional for you to put in your name, but in case we don't get a chance to address your questions in time, we hope you could leave your name and email and we can come back to you. Now, without further ado, please allow me to hand over the stage to Jesper.
Thank you, Jade. Thank you for the introduction, and thank you all for this opportunity to address so many people at the same time. It's always a pleasure to be able to give some information about our development and our latest service letters which have been issued. I will be talking today on the low sulfur service experience that we have. So this is a huge change for the industry and for our engines in itself, and also something that is tied together with our dual fuels setup, which is evolving. And we talk about dual fuels, alternative fuels, and they are becoming more and more profound in our development and in the market in general. Not just because of the dual fuels, but if you look at this timeline, for example, you can see here that the quest for these alternative fuels started already back in 2011 when we started the first test in our research center in Copenhagen. They soon evolved into the first deliveries that came out with the MEGI engines, the Easter Weather that came into service in 2014, and then evolved into methanol and LPIGs and whatnot is coming at the moment, ammonia for the future, the MEGA engines, which are just coming into service as we speak. Very interesting times and a lot of changes which are coming, and something, of course, that has to be taken into our design of the engine, but also into the cylinder condition, especially that it's as always challenged by changes that comes into this. It's not only the fuels actually, or the dual fuel concepts which are challenging this. As a whole, the sulfur cap brought on similar challenges to this as we see with the dual fuel engines and the new fuels which are coming in. So the sulfur cap have really changed a lot for the cylinder condition. We were very much afraid what would happen in 2020. this was we put numerous service letters into the market also to try and buffer the transition. It went rather well. We had a very hectic year with a lot of liner seizures coming from the fuel switch, but since then we have gotten to know how the engines are behaving under these new fuels. And it's interesting to think about that what actually happened was a overnight switch from a let's say 80-90% high sulfur operation, which had its impact on cylinder condition, into a 80% low sulfur. And I say low sulfur because very low sulfurs and ultra low sulfurs behave evenly inside the engine when we look at the cylinder condition. And what is remaining is a very small portion of the industry still running on high sulfur. And even for this small fraction running on what would be, you would say, the same as in the past, they have also seen a lot of changes because the fuel sulfur content has been pushed all the way to the limits of 3.5% sulfur, making corrosive engines even more corrosive or even more impacted by the co-corrosion that comes from the sulfur in the fuels. So we, at the moment, actually have two types of fleet. You could say we have a high sulfur fleet, which has to be dealt with in that aspect, and we have a low sulfur fleet that has to be dealt with in their aspects when we talk about the cylinder condition. Now, the typically normal issues that we need to address when we look at the cylinder condition is looking at the wear trends or the wear rates and the impacts on wear that we have. And these are profoundly these three types of wear regimes. So there is the abrasive wear that originates typically from abrasives in the fuels, could also be in the ingress air. So it could be cat fines, could be sand dust. These are causing, of course, wear, especially to ring grooves and to some extent to piston rings also. We have the adhesive wear or liner scuffing that that all are fearing. We feared it also with the 2020. It is actually not as extensive as you would imagine. We see some cases, but it's not many issues we're having with that. Co-corrosion remains an issue for the high sulfur fleet. And what has become a new interesting challenge is for these low sulfur fleet, which now is the predominant market share. So let's say the 80% of the fleet, which is operating on low sulfurs, very low sulfurs, ultra low sulfurs, or the dual fuel engine groups, they're all faced with a issue of keeping piston rings, piston ringlands and ring grooves completely clean. And if we don't, we end up with serious issues to the piston rings. Well, this is the challenge that we see for the low sulfur. So I tend to say it's controlled corrosion for high sulfur and it's controlled deposit for low sulfur. Now, the reason why detergency, cleanliness is important is that you have to look at the piston rings and imagine the function that they have inside the engine. They are the sealing surface between the piston and the liner surface, and they are flexible and they have to move. They have to fit to the deformation of the liner surface. They have to adjust to deformation of the piston crown itself. They have to adjust to liner wear that also has been caused over time, and for this they need to move freely. We need to get combustion pressures to the back of the piston ring to secure a seal against the liner surface. And all these things are challenged if there is heavy deposits. We've tried to address this both from a mechanical point of view. So you say there's different solutions to this. From the engine design, we have opted our ring packages. We have moved from 4 piston rings, which have a continuous leakage of gases, to a 3-ring package configuration. This seals up the gas flow through the ring package, and this gives less thermal stress to the cylinder oils. It gives less pressure loss also inside the engine, so it's a benefit for both operators as well as for the cylinder condition. And we have just as much addressed it in our cooperation with the oil industry, where we are cooperating with the oil majors in developing the new oils. And these category 2 oils is coming from a push from our side to ask for higher performance oils. And this has a huge impact on this cleanliness. The category 2 concept is actually to break away from the relationship between cleanliness and BN. So keeping the low BN oils at the same detergency level as the high BN oils are, so that we keep the engines just as clean, regardless of whatever sulfur level the engine is operating on. Pushing forward a little bit, I can tell you that this is actually there are some positive sides to this, and that's also the reason why we need to focus on cleanliness. If we look at the wear trends for the engines which are operating on low sulfur, very low sulfur, it's very low, and this means that you can actually achieve a 5-year time dock-to-dock operation without having a piston ring exchange, as far as you keep the engine clean and everything operating to our satisfaction. This is reflected in the fact that we have increased the TPO for the low sulfur fleet. We can also broadcast it. You can see this, the wear trends for the MBGI engines here. These are actual numbers, actual wear trends that you're seeing from 3 different ships, and you can see here that they actually managed to run the 33,000 running hours between dry docks. So it is realistic. We are seeing ships already which are able to run dock to dock. And if you look at the liner wear trends here in the bottom right corner, you can also see that the liner wears are actually extremely low. And this again challenges the engines. You have to keep everything spotless clean to achieve this this dock-to-dock opportunity. But it's definitely something that we encourage to try and achieve, to keep the piston rings running for as long as possible. And for that, we need to pay much attention to the cleanliness when we look at the low sulfur fleet. If you have any interest in studying more on this, there is a CMIC paper from this year that you can also deep dive into if you want to address it. I can only encourage that. There's not enough time today to elaborate that much on those actual service experiences, but there is information that can be gathered if you go into the CMARC website. Now, all this culminates in these 2 service letters which we're addressing today. So the service letters which were issued summer this year was the 737 and the 738 service letters. It's a sister pair. One is the guidelines for lubrication. The other one is the guideline for drain oil sampling or for follow-up on the lubrication scheme. So one putting the scheme, the other one giving you tools to actually control the behavior inside the engine. The key takeaway from the service letters, the lubrication guideline 3.7, is the fact that for all engines Mark 9 and higher, we are recommending to use what we call a category 2 oils. So these high performance oils, these are what we are specifying for the new engines and for the future engines. These oils, I'd like to stress, is also something that you can use for the older engines. They can be applied to Mark 6s and whatever ratio you have the engines. The new oils are fully compatible. We see no issues in using it for MC engines if that should be the case. They will give solutions if you have deposits also on the older engines. For the high sulfur fleet, we see I think a necessity to also stress that the possibilities of moving to 140 oils, these are not new in the market. These have been in the market for a long time, but we're not seeing that much use of it, and we see a lot of owners who could benefit quite a lot from moving into higher BN oils when they're operating on a high sulfur, and especially since the sulfur in the fuel market has moved to the high end, then this makes perfect sense to move also to the high BN oils. This we also try to address in these service letters. The service letters also contain a list of these recommended oils. It's quite list very full of different scenarios. But again, the takeaway is simple, saying that if it's a Mark 9 or higher, then it's category 2 oils. Then you choose your BN in relation to your fuel sulfur. As long as it's a category 2 oil, the detergency will be in scope with the sulfur neutralization. You have a little bit more freedom when we look at the older engine types as it is, but still category 2 oil is the solution oil here. Other changes to the service letters is also to pay attention to that for the CPP for controllable pitch propellers. We are moving our breakpoint, increasing it from the 25% power, 40% MEP, to 63% MEP, which is 50% engine power. And this is to secure against the higher wear rates that we typically see on these CPP plants. So that's a note to take away also for the crew to remember if you are running with a CPP propeller. Looking at the other service letter, the 738, which is, as I said, is the sister to the 737. So this is looking at how do you evaluate the scheme that you have put forward for your lubrication. We have updated our iron BN chart. We have removed the ball polish section that we had in the lower corner. The reason for this is actually service experience showing that you can run with high BN oils for a prolonged period without seeing necessarily any liner seizures. This has been a necessity as we had problems with keeping the engines clean. So we saw no other solution than to move into high BN oils to secure the cleanliness with the fear of ending up with a ball polish issue. But actually, we did not see any increase in liner seizures as a result of running on high BN oils. So it seems difficult to obtain a fear of the ball polish situation. So today we are saying that you can use a high BN oil even with low sulfur. It should not pose a threat against liner seizures. But of course, there are other issues that is pushing us to say that you should use the lowest BN possible. And these other issues is that you have to take into account that there is a particulate coming from the cylinder oils, which will be fouling up your exhaust system. It will be fouling up, polluting the air, but also for engines running with EGR systems, you will be putting extra strain on the EGR cleaning system. So trying to keep with the lowest possible BN will help the other systems, not as much the cylinder condition, but there are other aspects to take into account. Drain oil sampling, collecting drain oil from the engine and sending it ashore for analysis, still something that we are recommending both for high sulfur and low sulfur. We recommend that this is done for every 1,500 running hours for onshore, ashore analysis. Very important to keep track of this. It gives you an insight to whether there are any pollutants coming into the cylinder system. It gives you an insight into other issues that may derive from coolers, stuffing boxes, and whatever it's not performing to the task. And therefore, we keep this for high sulfur. It's of course very important to do this to make sure that the cold corrosion is under control. And also there is this possibility of running onboard drain oil analysis, which is also something that we recommend. It gives a huge benefits both for low sulfur and for high sulfur. Of course, with high sulfur, it's important to keep note that the BN also has to be checked and kept in accordance to our recommendations. Otherwise, there is a risk of having high wear inside the engine. The sweep test, which has been in our recommendations for a number of years, is still valid, but only valid for the high sulfur fleet. So please don't do sweep test, stress tests on engines which are running on very low sulfur or ultra low sulfur or dual fuel engines. You will end up with straight lines. You won't see any corrosion pickup when you lower the feed rates. So this is a tool intended for new high sulfur operated engines to give you an indication of where the feed rate factor should be adjusted. And from this, you can, of course, adjust your lubrication scheme, but you can also use this to guide you towards which grade of cylinder oil you should be using. Again, a new recommendation from our side: if you observe that the feed rate factor is higher than 0.32, we recommend that you try to address whether you can have a higher BN. So if you're running 0.32 on a BN 100, then we would recommend you to seek a 140 BN oil to see if you can lower down this feed rate factor. The reason why we want to reduce on the feed rate factor is that there is a loss of oil inside the engine, and the higher feed rate you are using, the higher the internal loss is. So your usability of the oils is not as good with high feed rates as it is with low feed rates. So the optimum is to go for a higher BN with a lower feed rate instead of running with a low BN oil with a high feed rate. It makes sense to go the other way. So choosing the lowest possible feed rate factor using the highest BN grade available, that's our recommendation for the high sulfur fleet. We also changed a little bit on our guidelines for the iron levels that you see in the drain oil. And the reason for this is that instead of having a bore specific relation, we say it's more important that you evaluate it against the fuel type you're running. If you're running on an ultra low, very low sulfur, you will observe very low iron levels, and you should be alerted much earlier than if you're operating on high sulfur. So these have been changed. And also new is that we are actually putting in some levels for a onboard magnetic reading. And this is especially for the low sulfur fleet, not as much for the high sulfur fleet, but for the low sulfur fleet, it makes sense to actually have an onboard test kit and do some testing here. And you can use this as a guideline, whether there's anything happening inside the engine, and get a fast and easy readout. But for high sulfur, be careful. BN is very important in these cases. And please make note that both normal and raised are actually what we would refer to as green values. It's only when you come into the abnormal and alert values you should react. Just a takeaway from my side. Cermat coating, very important to record this. This is your indication of wear inside the engine. If you have liner wear, you will also have Cermat coat wear. If you have corrosive wear, the Cermat coat will reflect it also. So this is an easy way to have a view of whether there is wear or not wear inside the engine. So I cannot stress enough to take these measurements. They're very easy to take. And we recommend to run with Cermat coated piston rings on all engines, regardless of whether it's high sulfur or low sulfur. And taking this measurement really gives you an insight, and keeping this is very important. I hope that that was a fast run through, I might add, but I hope that gives you some insight to the service letters and the importance of looking at these things. This is finishing up with me, and I'd like to switch over to Dirk, who will then continue on Shell's behalf.
Thank you, Jesper, for a good kickstart of this webcast. Thank you, everybody, from joining from all over the world, and greetings from Rotterdam. These guidelines from MAN, these updated guidelines, we have our Shell Loop Monitor service ready, and we're going to present you some actual cases that we have logged in this service. All of this is backed up by the OEM guidelines, in this case MAN. We will look at MAN engines, and I will quickly go through the agenda for the coming 20 minutes, what we will be reflecting on. So it will start with the cylinder lubrication feedback loop. And then we focus on the importance of the running in procedure, also highlighted by service letter 737 mentioned by Jesper. Then the two challenges that Jesper also reflected on. The two challenges are corrosion control and deposit control. We will look at example cases. So why this is important to monitor that closely. And we end up with the summary with Marcus and the key takeaways. We start with the cylinder lubrication feedback loop, because different to other lubricated systems like trunk piston engines, where we typically just top up as per consumption, two-stroke engines have a lubricator. And the lubricator needs to be set. First of all, the right lubricant has to be selected. And then it comes back to the feed rate. The right feed rate has to be selected. And 10 years ago, we saw some cold corrosion coming up in the market. There we have learned to look at the cylinder drain oil samples to get more information. Now we will see what is important these days. As Jesper also reflected on the engine portfolio, there is a huge variety of fuels will be coming to the market, and the engines, which are basically just an energy converter, will be ready to convert these different types of fuels into mechanical power. Challenges are really varying. It comes, engines are different because the fuels are different. The legislation will be different. Sustainability is a clear angle, and the CII, the carbon intensity index, will demand the speed to reduce. All these different aspects are coming together in the combustion chamber. The combustion chamber is having all the information required to come up with the right lubrication. That is cylinder oil selection and setting of the feed rate. All these different aspects we need to look at. So that is quite well described in the service letters, and it's all implemented in Loop Monitor, as we will show in these cases here. Now, here we're looking at the case. It's a Mark 9 engine running on very low sulfur fuel. It's a category 1 Shell Alexia 40 at 1.3 grams per kilowatt hour. The measured iron concentration was 16 ppm. So the service letter is telling us to correct the iron on a reference level, and the reference level is 1 gram per kilowatt hour, and then to judge whether the iron is okay or not. So here we're looking at a low sulfur fuel burning engine. So if we correct the 16 ppm to the reference level of 1 gram per kilowatt hour, we see it's 21 ppm, which is quite low. But please have a look at the picture next to it. And remember what Jesper has shown on the function of the piston rings and the importance of keeping the ring lengths clean and to keep the deposits, keep the ring grooves open, to make the gas pressure press the rings into the liner. Here we see a challenge, and that is not reflected by the cylinder drain oil samples, because the iron level is low, but still, does that mean the cylinder condition is okay? I don't think so. So what is important to look at, it's this feedback loop, and that's where Shell Loop Monitor is playing a key role. What we need to collect is the cylinder oil in use, the current feed rate, and the fuel sulfur percentage. Next to that, we want to judge the inspections from the engine, the onboard testing, and the laboratory testing, as reflected by the service letters. This complete picture gives us the information to advise on the cylinder lubrication. So cylinder lubrication, again, that is the cylinder oil selection and the feed rate. To start with the running in procedure, because we have seen often it has not been completed towards the minimum feed rate, and that's a very important one. On this case, we have documented in Loop Monitor. Here we see a Mark 10 engine while going through the steps of running in. So on the graph below there, you can see the cermet coating thickness. Well, it's the coating thickness. It's made of cermet coating and alucoat. So the aluminum coating is the running in coating, and the cermet coating is the wear-resistant layer that's underneath that. So the actual coating thickness is the sum of both. So you can see the color of the rings change through the steps. So the points on the graphs are showing the hours where it has been taken. And we can see the color changing of the rings. That's the aluminium running in coating, wearing off. So it's all as per normal procedure. And each time, for each step, when the feed rate is reduced, so we can see it through the steps that the feed rate is reduced, it is confirmed the cylinder condition is clean. So cylinder condition is clean. So next step, reduce. So that's the loop that we are going through. So check condition, reduce feed rate, and document it. Loop monitor would help with that to get you to the lowest possible feed rate. And that's important to achieve. The two challenge, we want to reflect that. That is on the sulfur percentage. So here we can see a simple graph with feed rates versus fuel sulfur percentage. So the challenges are already mentioned by Jesper, and it's really depending on the fuel sulfur percentage. It's polarized. So we can see deposit control in the low sulfur area, where we recommend to aim to operate the engines in the yellow areas. So for deposit control, stay below 1 gram per kilowatt hour, preferably between 0.6 and 0.8 grams per kilowatt hour. In the high sulfur case, typically above 2%, as Jesper has shown, we are aiming to stay within this yellow graph that we are seeing here. So it's depending on the feed rate factor determined, and that's in fact the sensitivity of the engine to form sulfuric acid for a certain fuel sulfur percentage. So let us start with corrosion control. That's what we have been focusing on since the last decade, and mainly until 2020, but it's still existing because there are it's a substantial number of substantial portion of the fleet is having a scrubber, and there we can see really high sulfur fuel that is used. So it's the corrosion control challenge. So let us look at one of these cases. Here it shows what we're looking at here. It are sister engines, so sister ships. And these are measurements from the liner. And it's a really trumpet shape. So for both of the graphs, we can see at the top, there is quite a high wear, in particular on the left-hand side. There you can see the red line is really showing a higher wear at the top than the other one on the right-hand side. So this is typical, both are typical for cold corrosion. The protection is required at top dead center. And here, the only difference here, the fuel is similar, the engine type is the same, the trade is the same of these vessels. The only difference is lubrication, as you can see here. So at the left-hand side, it is Shell Alexia 100 at 1.2 grams per kilowatt hour. And at the right-hand side, it's Shell Alexia 140 against 0.8 grams per kilowatt hour. So where the arrow is pointing at, that's the level of injection of the oil. So it's 1/3 from the top. When we are collecting the scavenge drain analysis samples, that's completely at the bottom. And you can see for both are indicated they're normal. At the left-hand side, there is more wear. But as there is more oil injected, of course, the cylinder drain oil sample at the bottom will tend to go to the fresh oil. So the more you inject, the more you will lose to the bottom, and that will kind of dilute your view. So this is showing that it's really essential to select the right oil and get to the right dosage, so feed rate. So if we go to the evaluation, we can see for both it is the first overall. So roughly at 17,000 hours. But there is an obvious difference in wear at the top. So one is closely to 0.8 millimeters and the other one 0.4 millimeters. So here we can see the difference in wear rate. And this is only because the right lubrication has been set at the right-hand side. So we can see the wear rate of 0.02 millimeters per 1,000 hours. That is really satisfactory. So that's an important one. So if we look at such a case logged in Loop Monitor, and remember the service letter is indicating to check the coating thicknesses, even for the cases where corrosion is a challenge. We can see here at the graph, if we're plotting the lubrication in the graph, that's at the red cross, we can see it's outside the yellow area. To get inside the yellow area, it means that we have to reduce the feed rate factor, and that can only be done by increasing the BN. So from BN 100 to BN 140. That would mean the cylinder is better protected, and there is not the risk anymore to suddenly, whenever the corrosion, the sensitivity is increasing, that the coating thickness is suddenly lost, as we can see at the graph at the bottom. Here, the top ring, the coating thickness from the top ring is the line at the bottom, and at some point, between two inspections, it suddenly, well, kind of disappeared, as you can see from the coating thicknesses next to the piston rings. So you can even see it if you look at the ring, that ring number 2 and ring number 3 are much more shiny compared to number 1. Here we lost the wear resistant coating, because wear resistant coating is wear resistance against mechanical wear, but not really to sulfuric acid attack. So that's the importance of checking the cylinder condition and make sure you select the right feed rate. So the next challenge, what we're going to focus on, is on deposit control. Again, the graph, but now we're looking at the low sulfur area. We have seen, and Jesper was also showing that the wear rates are really, really low. So this is a graph from Shell Loop Monitor. For the case we're looking at, it's a Mark 9 engine, very low sulfur fuel. The feed rate is 0.86 grams per kilowatt hour. Initially, the coating thickness is coming down relatively fast. That is the running in coating. And then for the last, let's say, 10,000 hours, it has been quite stable. There is no actual wear anymore. And the expected service life is 16,000 hours. Well, it's clear that the wear rate is not a challenge at all. If we then look into the inspection results, we can see at the first ring length, these are typically most sensitive to deposit formation, that there is a challenge, and that's the deposit control challenge. So it is indeed recommended to go to a grade with higher detergency to make sure that the rings we keep the rings moving, to potentially even run from dock to dock, because the wear rate isn't the issue. And if we then also solve with a category 2 lubricant the deposit challenge, then we have nailed it, and you may run from dock to dock with such an engine. Now, we're really keen on this first ringland and even any tendency of deposit formation, as we can see here. When this vessel started to log into Loop Monitor, we found early signs of deposit, as you can see at the left-hand side. It's very thin, and there's no way this picture or this cylinder condition is not critical at all, but there is early sign of deposit formation. And by default, this customer was mixing a category 1 with a category 2 oil, just 50-50. Upon these results, we have recommended to go for a category 2 lubricant. And it was even possible to reduce to 0.6, as you can see at the right-hand side. Here, the deposits have disappeared, completely clean. Then if we, from that moment on, we're looking here at the same engine, but we kept on monitoring it. So the customer kept on confirming the cylinder condition is good. And we can still see here this golden yellow running in coating. So even though it's at 0.6 grams per kilowatt hour, the running in coating is slowly, really slowly disappearing. And when we use Loop Monitor to make this extrapolation to see when piston overall would be required, we see it's way beyond the expected service life of 16K. Even though the full wear-resistant ceramic coating is not exposed to the liner yet. So even this is a pessimistic view. It will only improve. The wear rate will even further stabilize. The cylinder condition is perfectly clean, so there is no need to go for an overhaul at all here. So for the key takeaways, we will go to Marcus Scherer, our General Manager from Technical Services. Over to you, Marcus.
Thanks, Dirk. Well, firstly, my heartfelt appreciation to Jesper and Dirk for their insightful and informative sharing. And also to the audience who have joined us today. I think it's not every day we have so many shipping experts gathered, also virtually. Shortly after I've joined Shell, this was April 2001, something revolutionary happened, and by the way, totally not related to me. After decades of using a 70 BN cylinder oil with a feed rate of 1 gram per kilowatt hour, Shell introduced a 40 BN cylinder oil. So suddenly we had 2 cylinder oils in the market. Why was this needed? In South America, there was a low sulfur fuel in the market, mainly driven by crude. And after decades of using a 70 BN, we needed an oil that can cope with a sulfur content of below 2%. And engine designers recommended a lower base oil number to reduce the risk of sudden severe wear. That's what we called that time. I think today we would say scuffing. Today, in our world, we have 5 cylinder oils in the market. 3 of them are category 2. We have a variety of fuels. And we have far more efficient engine designs. It's very obvious that the complexity has increased and the focus has changed. The combustion of very low and ultra low sulfur fuels have resulted in a shift from corrosive control to deposit control. The visual inspection can be used to provide essential feedback on cylinder lubrication settings. There's an increased need to identify the minimum acceptable feed rate. And there's higher emphasis on ensuring that the maintenance records are kept in a structured way. Can someone move to the next slide, please? Thank you very much. As we have learned, the way we manage and monitor 2-stroke engines is certainly way more complex now. But complexity, with a capital C, can be managed by 3 other C's. And these 3 C's, number 1 for me is collaboration, or how I would call it, connecting the dots. I usually start with customer first, but in this case, please accept that I would like to appreciate the strong collaboration with OEMs and especially with the team from MENES represented by Jesper today, without which we would not be able to support our customers the way we can. And then it's a great collaboration with our customers. Many of you are in the call today, and I'm super happy and appreciative of it, who openly share challenges and observations and even allow us to use their ships to test new solutions and learn together. Collaboration. The second C for me is competence. And again, people like Jesper coming up with modern and highly efficient engines that can burn various fuels, but also require a different type of monitoring. We have people like Dirk, who can support you by designing modern and intuitive platforms like Shell Loop Monitor that not only use data science, but also is enhanced by our technical insights from real human experts. Which leads me to our Shell Marine technical advisors in the field who work closely with you, our customers, supporting superintendents and chief engineers, the experts of our customers, which by the way is another very important C. Last but not least, it's care. It's care for details to ensure your engines are monitored and lubricated in an optimal way. It's care for your crew, who more and more need to deal with all this increased complexity we talked about in this call, by providing meaningful advice and support and create peace of mind with tools who simplify and standardize the monitoring of your engines. So Shell Marine, with its range of Alexia cylinder oils, offers you the right products and the right technical support and service to maintain and monitor your cylinder condition in line with latest guidelines from engine manufacturers like MENES. Thank you very much. With this, I hand over to Jade.
Thanks so much, Marcus, as well as to Dirk and Jesper for that informative session. This concludes our content sharing session, but we're happy now to take on your questions. Once again, please do click the question mark icon that you see on the screen in the top right-hand corner, and you can type in your questions. With that, let me just start. We actually have a lot of questions coming in, so thank you very much. First question, and I think, Marcus, maybe you can take this on. Will Shell Loop Monitor work with future engine designs?
Loop Monitor started as an Excel spreadsheet many years back, and we developed it during the time. And we developed it based on the collaboration with engine manufacturers and OEMs. I think today we don't know how future designs will look like. What we know is complexity will increase. We will manage this by collaborating together. We will get new service letters, we get new requirements, and we will learn on the go. So for sure we will adjust. For sure the collaboration will continue. We will see new complexities and new situations that need to be managed, and Loop Monitor will evolve to help our customers and crews to manage that complexity. So maybe Jesper, you want to say something on this?
Yes, I fully agree. The guidelines, no doubt, will be updated in the future. They have always been, and they will continue to do so. We continue to adapt our schemes and our instructions for how to maintain the engines, to optimize on time between overhauls, to optimize on wear rates, to give the best benefits to any operator. We have this cooperation with the oil companies, with Shell and others, and here we of course always give our guidance, and we give all the assistance we can to achieve the best guidelines for the operators, whether it's coming from us or whether it's coming from Shell. We are trying to achieve that it's the best, let's say, cooperation and the best recommendations going out. So as long as Shell is updating the Loop Monitor and we have our cooperation, then I'm sure that you will be in key with our latest recommendations, that's for sure.
All right, that's great to hear. All right, I'll move on to the next question. What is the difference between Shell Loop Monitor from other competitors? Okay, interesting one. Dirk, would you like to take that one?
Sure. Biggest difference, that's what we have built in over the last, well, let's say 5 years, when the deposit control came up. when we saw the challenge, and that is to take in all the observations from a physical inspections. So the engine stuff is recommended to do on a monthly basis a scavenge port inspection. So to measure the vertical clearance between rings and grooves, to measure the coating thicknesses, and to assess or make a rating of the cleanliness of the different pistons and the lubrication condition, preferably with pictures. So we are collecting all that. So together with the onboard results from the onboard test equipment and the laboratory equipment, what we have seen with other oil majors as well, we haven't seen another service provider coming up with a system to collect all the required information related to detergency, related to coating thicknesses. And as you have seen from the presentations, this is key. And please take the service letter as a reference. That is key. The assessment of the cylinder condition. And that is key to give the proper recommendation on lubrication. Select the right lubricant and aim for the lowest possible feed rate. And that can only be done. Detergency cannot be read from a laboratory report. Piston cleanliness, we need to have access to the visuals of a piston to assess the cleanliness. And only there we can recommend the right lubricant and make sure you will reach the next docking and not a sudden overhaul is required of the units. So that's the biggest difference between Loop Monitor and the offering from other service providers.
All right, thank you so much, Dirk. Moving on. What's happening to BN70 oils in the market? Jesper, you want to take that?
Yes, I can discuss it. Yes. Well, it's interesting actually. So we have been accustomed to this 70 BN oil, which were one size fits all for the past decades that we have had. It's interesting to look at the high sulfur market as it is. As I said, the sulfur is moved to very high sulfur levels, and the predominant fleet is moved to extremely low sulfur levels. And where that means actually that sulfur level where the 70 fit into the picture is actually missing. There's nobody operating on a 1.5, 2.5% sulfur. Most operators on high sulfur is running above, and they need 100 BN oil. They need 140. For the low sulfur fleets, we do not need 70, and for most of them, the traditional 70 do not keep enough detergency to keep the engine clean. So as it is, the 70, as we know it, is becoming, let's say, not high enough in performance level. So I see that it's not really suitable for the future. We will be looking at category 2 oils for all future engines. All our focus will be, regardless of BN level, it will be on a category 2 solution. If the sulfur actually becomes in that midsection 1.5 to 2.5% sulfur, then we would be looking at a BN70 category 2 oil, not the old traditional 70. So I think that we have to come to terms that the 70 is not completely fully applicable to the future we have at the moment.
All right, thank you, Jesper. Moving on. Doug, I think this one's, you could take this one because it's for Shell. Does Shell have any plans of conversion process? Our existing ships have been doing inspections and sample analysis, but the cleanliness of the engines have not been showing good results.
So good question, and that's the typical deposit control challenge. Service Letter 737 is having a very good appendix looking at that. So if there is a certain amount heavy or medium deposits on the ring lens, it's recommended to increase the feed rate, increase it by 0.2 grams per kilowatt hour. But, and as we often see, feed rates are already high. If you're already at 1.0 grams per kilowatt hour, that means further increasing, it doesn't necessarily help. So there it's recommended to go to a higher detergent grade. So in such a case, when a category 1 oil is in use and you already reached the 1 gram kilowatt hour, it is necessary to change over to a Cat 2. And that can be done in the next order. The oils are compatible, and then keep on monitoring. And for sure, the detergency or the piston cleanliness will improve. So that's the conversion process. It's simply to apply a category 2 lubricant and to make sure you optimize the feed rate. And it sounds strange, maybe representing an oil company, but I have to say, in Shell Loop Monitor, we've seen the best results with the lowest feed rates. So aim for the lowest possible feed rate and keep on doing all the checks that are required.
All right, thank you so much. Jesper, I think we're getting a lot of questions. So Jesper, I think this one might be for you. For running in new liners or rings, we utilized mineral oils. What is the man position on this now?
Well, our position is to have a lubricant that is suitable both for running in as well as for normal operation. We are not. We don't want to have too many grades. We're really trying to minimize the number of grades which needs to be carried on the ships. It's a complexity if you have to have multiple grades. So if you were to move away from mineral oils for running in purposes, that would be a complexity added on. No doubt also an extra cost. That's not in our scope at all. So we are looking at using the oils which we use for service, also for the running in purpose. It works. So we're looking at a multiple use oil. That's our goal, to secure a ease of delivery of oils worldwide, not having specific oils for different purposes.
Thanks, Jesper. And Marcus, I think I have a question for you. Looking at variety in fuel, including alternative fuels, will it be going to one cylinder oil in the future, or will it be tailored to each type of vessels, engine types, and fuel types?
It's probably something in between. I don't think we will produce a tailored per engine type and fuel type, but we will have more cylinder oils. I mean, at the moment we are sure that the Alexia we have in the market, especially the category 2, are suitable for methanol use. If you talk about ammonia, I think we talk already about something different, where we need to develop a new fuel. And I think we talked about the 70 BN who might disappear at some time. So our portfolio will vary, and our portfolio will change. While we talk and have this webinar, our friends from research and development in Shell are looking in collaboration with the OEMs and with MAN and with Jesper into what is needed to run an ammonia engine safely and properly. And there will be new fuels, new designs, and new challenges we are not aware of today, which leads back to we need to connect the dots, we need to stay close, we need to collaborate, and we do. And step by step, we will progress. We will see new complexities, we need new situations, we will see new service letters, and this will evolve. It has evolved over the last 20 years, and it will continue to evolve. And we will stay on top of this curve together with our friends, colleagues, partners, and customers.
Thank you, Marcus. And
I'm not sure if Jesper has a view on this.
No, I agree. If I can, or if we could stay with a single oil for all multi-purpose, we have that at the moment. I think for low sulfur, very low sulfur, you can operate very low sulfur, ultra low sulfur on a single lubricant. You can run with the BN40 category 2, and that would secure you on both types of fuels. So going in and out of ECA on a very low sulfur fleet, you are actually in that beneficiary condition that you can use a single lubricant. It gives it easier for you to actually secure it for the ship. and less complexity for the owner in that aspect of having to carry different brands. You don't need that. For high sulfur, we're not in that lucky situation. You can operate for a period with a high BN oil. As I said, this bore polish has been omitted. That means you can actually go into an ECA area with a high sulfur fleet and then continue with your high BN oil. We don't see that as a big issue. And that again gives you a benefit of possibly only being on one lubricant. But for the full portfolio across all the engine types, we still need a high sulfur solution and a high sulfur solution and an ultra low sulfur solution and maybe an ammonia solution, because we're not sure how that will be. If we could have a one size fits all, that would be nice. But then again, I'm not sure if financially it's feasible. We wouldn't want to push an extremely expensive oil on all operators just to benefit a couple of few operators.
Thank you, Marcus and Jesper. And that is actually a very popular question. I think, Dirk, this came from your presentation. Why is deposit an issue of recent focus?
Deposit is in the recent focus because for the traditional oils, the detergency is coupled to the BN level. So a high BN gave good, proper cleanliness. As Jesper has explained, for the low sulfur cases, it's not directly an issue for the cylinder condition to use a high BN oil where there is no sulfur to neutralize, but it's for the systems more downstream. So waste heat recovery boiler, a catalyst or whatever. For that, it's important to apply a low BN oil. And as traditionally the BN is coupled with the detergency, Jesper had this graph with the clouds where it was explained. Now it is required to decouple that and have a low BN oil with a high detergency, so at least similar to a BM100. So that means a BM40 and a BM100 with the same cleanliness ability. And there we have seen the challenge. When a traditional BM40 classed as category 1 has been used, the deposit issues came up. So for that, a category 2 lubricant is required. Low BN, high detergent oil. That is required for satisfactory operation. So that mainly came with the IMO 2020 fuels. That's answering the question.
Yeah, thank you so much, Dirk. Jesper, I think this one is directing at you now. You mentioned that the high BN cylinder oil can affect the scrubber system or other components of the engine. Do you have any case studies to show the results, which is use of low BN against the high BN oil, and how and where exactly it had an impact? Let me know if you want me to break up the questions for you to answer, because it's quite a long one.
Yeah, no, it's okay. Okay, I'll break it up myself.
Okay.
It is, they're right. Perhaps the scrubber system is not the big issue if we're talking about a high stock scrubber. If we look at the newer engines that we're pushing into the market at the moment, we have a lot of engines running with what we call with the EGR, exhaust gas recirculation, and that means we're taking the exhaust gas with all the soot and all the deposits that may be coming both from fuel and from the lubricants, and we need to clean this to be able to push it back into the intake air to lower down the NOx, and this actually is something where we have to clean the water that we use to clean the air, and that extra particulate that may come from using a high BN oil will end up in that kind of system and end up as a pollutant that you have to take care of. And I know as it is today already, the strain on these cleaning systems is very high. There is a lot of particulates that needs to be removed in separators from the EGR systems, and these are what we're trying to look at, whether we can reduce it. There is a higher number of engines with exhaust gas recirculation, not only the MEGA engines, but also what we call the EQ EGR systems, which are running continuously with this exhaust gas recirculation, and we will see that more in the future, I'm sure. And that's where we're saying that system will then be strained by higher particulates that we see. So lower feed rates will mean less oil, that will give less deposits, less particulate in the exhaust gas fumes. Lower BN levels preferably will also give us lower ash levels, and that again also will give us less strain on this cleaning side that we have.
Great, thank you. And actually, we do have another question, yes, so on feed rate. So if you could just stay on again, I think you're a popular man. If we reduce the feed rate as recommended by MAN, all that's going to happen is that the iron content is going to increase and lead to ring or liner failures. How do you mathematically balance it out?
You can, if you look at the high sulfur fleet, you can look at feed rate and iron as a correlation to each other. So when you lower down the feed rate with a specific, if you're running with 100 BN oil and you lower the feed rate, then you'll see the iron to start to increase. So here you can see that that correlation. And here I wouldn't say just lower down the feed rate. If you lower down the feed rate, you have to move to a higher BN grade, and this will then keep the iron levels under control with the lower feed rates. But that's only for high sulfur. If we look at very low sulfur, ultra low sulfur, all the dual fuel, we don't have that correlation. Feed rate and iron doesn't impact to the same. So you see the reduction in feed rate, and the iron continues to be the same very low threshold. So you're seeing 20 ppm of iron regardless of the feed rate. So you can actually adjust the feed rate without any fear of high iron levels when we talk about very low sulfur and ultra low sulfur. It's only on high sulfur you have to the disconnection between feed rate and iron, and that's why I said that's the control component, control corrosion, where the oil is no longer used for lubrication purposes. It's used to bring in alkalinity to control the corrosion, and here the BN grade is extremely important to keep into the assessment when we talk about reducing feed rates, feed rate factors, sweep tests, and etc. But the opportunities for striving for the low feed rates, that's for the very low sulfur, ultra low sulfur fleet. Here there are these possibilities actually to have a very low consumption of oil, still have a very low iron level, and practically zero wear inside the engine. And we should try to achieve that to everybody's benefit.
Thanks so much, Jesper. Marcus, we have one for Shell. What are the available Shell oil grade with low BN, high detergency?
Oh my God, I would lose my job if I can't answer that question. The grade is Shell Alexia 40XE, so the category 2 cylinder oil from Shell.
Thanks, Marcus. Do stay on. I think we've got a question here from the ASEAN market. So in the ASEAN market, there are some rules from the government for using biodiesel. How will Shell and MAN respond to this regulation? I think, Jesper, you might also want to answer after Marcus.
Well, related to two-strokes now, I'm not sure if you talk about four-stroke or two-stroke, but related to two-stroke, the use of biofuels isn't a problem, or that hasn't shown to be a problem. We strongly recommend the condition monitoring as described in this course. I know there's a special MAN service letter on the use of biofuels, and this is probably the avenue to hand over to Jesper to answer the question.
That's true. I would say that if we look at the cylinder condition isolated, remember that the fuels are combusted when they have an impact on the lube oils, and regardless of what fuel we're looking at, whether it's a gaseous fuel or liquid fuel or biofuel, it's usually carbohydrates, and it ends up as the typical flue gas that we normally see, and that impacts in a similar way as other fuels does. So I don't expect necessarily any major issues running on biofuels towards the cylinder condition. We've run tests and not seen any different impact. Again, they're combusted there, and once they are into flue gas, it impacts similar to other fuels that we see. There can be some other issues that come in, and that can be on the fuel system itself, seals, and etc., where the biofuels can be aggressive, and that's more of a challenge. But that's a mechanical challenge, you could say, to the engine design. There may be some things that needs to be updated in that aspect. But sure, we can run on it, and we can lubricate it, and I don't expect that we would need a different special lubricant for biofuels at all.
Thank you, gentlemen. And I know we're running out of time, so let me just ask one last question. And I hope I got this right, lots of terms. Is 1.4 grams per kilowatt hour not very high consumption for an ME engine with alpha lubricator?
It is very high. It is very high. Anything above 1.1 gram, in my terms, would be high. And we many years ago, we requested these 140 BN oils actually to try and attack these very high feed rates. So we are capable of running up to 1.5 grams on the engines, but that's not it's not a sweet spot. As I said, anything above 1.1 gram, you have to realize that you are losing an amount of oil into the scavenge frame box by itself, because we simply cannot obtain that high feed rate of oil. We don't get the full utilization. Dirk had a very nice slide showing the wear trends that you can see using a 100 BN oil towards a 140. You actually get better protection with the 140 than towards a 100, simply because even though you're increasing the feed rate with a low BN oil or lower BN grade, we cannot necessarily transport it to the top of the liner for utilization. We may lose a lot of it inside the engine. And that loss also have to be compensated with a higher feed rate. And again, it just makes it even more evil to run with high feed rates. So the lowest feed rate possible, highest BN grade achievable, that's the sweet spot.
All right. Thank you. And thank you so much, gentlemen. We have actually gone over time, but that only goes to show there's a lot of participation. So thank you to the audience as well for your many questions. As for the remaining ones, hopefully you've put in your name and email so we can come back to you. So for now, please do go back to the lobby. We hope you could take the time to leave us a feedback on this event. You may also put in within the open field your questions. You could also browse the you could also browse the lobby to go in and review all the Shell Loop Monitor and the Man Service Letter assets. And if for those of you who want a bit of fun, why not try our Shell Marine Seaside Sprint game that we will be having prizes for the top 5 scorers. And of course, the lobby, the virtual lobby, will also be where you can access to the webinar recording later. Please note, the lobby will be open until this Friday, October 27th. So please do browse it. Yeah. With that, we hope you have enjoyed the webinar. Thank you all again very much, and goodbye.